Hello everyone, I am Dr. Raman. In this section we are going to discuss with Cauchy residue theorem problem. Look at this problem. Evaluate integral over C tan Z, where C is the circle modulus of Z equal to 3. So here f of Z is nothing but tan Z. The tan Z sin Z by cos Z. Now find, to find poles. So denominator equal to 0, cos Z equal to 0. When cos Z 0, the Z point plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2 and so on. Then the points are 0, cos Z 0. So this is our poles. To check these points are inside the circle or outside the circle. Now the circle is nothing but Z3. Modulus of Z3 circle. Therefore this is the x-axis and y-axis. The point 0, 1, 2, 3, 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. Then this is our circle. Circle 3. So this is our region. So this is our region. Modulus of Z equal to 3. See here the points is nothing but to check each point inside the circle or outside the circle. This is a modulus equal to 3. The first point is equal to pi by 2. The pi by 2 is nothing but 3.14 by 2. It's a 1.57. Simple pole, because the power 1 simple pole lies inside the circle. Inside the circle, because 1.2 this is a point. Then Z equal to minus pi by 2. So minus 3.14 by 2 minus 1.57. This is also simple pole lies inside the circle 3. Then Z equal to 3 pi by 2. So 3 into 314 by 2, 4.71. This is also simple pole, but this is a lies outside the circle. Outside the circle. So the points is 4.7. So I think when I consider this is a 4 and 5, the points here 4.7. So outside the circle. Similarly, Z equal to minus 3 pi by 2 also 4.71. Simple pole lies outside the circle. Therefore, Z plus or minus pi by 2 inside the circle, Z plus or minus 3 pi by 2 plus or minus 5 pi by 2, all other points are outside the circle. Therefore we have 2 points. We have 2 points, residue 1, residue 2. So anyway, here whenever I am looking the form Cauchy residue theorem, evaluation of residue having 3 formula. Evaluation of residue 3 formula. One is simple pole when Z equal to Z naught. Then second formula, pole of order n. And the third formula, if pi of Z by psi of Z, then pi of z by psi of z, then pi of z, the residue pi of residue z equal to z naught, pi of z naught by psi dash of z naught. This is also simple pole at point z naught. So now I am going to apply with this third formula. So third formula, therefore in this third formula, when I consider tan z, so integral over c tan z dz equal to integral over c sin z by cos z dz. Now the function is if f pi of z psi of z, so let pi of z sin z, psi of z cos z. Now the derivative of psi dash of z minus sin z. Now the point, at the point z equal to here pi by 2 and then minus pi by 2 residue value, other values are outside the circle. So therefore these 2 points only to calculate residue pi by 2, residue pi by 2. Therefore this is a residue 1 when the condition if pi of z psi of z, then residue z equal to pi by 2, then residue 1 equal to find this points also, the points is nothing but pi of pi by 2 equal to sin pi by 2. So sin pi by 2 1, psi dash of pi by 2 minus sin pi by 2 minus 1, and then pi of minus pi by 2 sin of minus pi by 2, sin of minus x equal to minus sin x, so minus sin pi by 2 minus 1, then psi dash of pi by 2 minus pi by 2 minus sin minus pi by 2. Therefore sin of minus x minus sin x minus minus plus sin pi by 2 1. Therefore first the point z pi by 2 is a simple pole at the point z equal to pi by 2. So residue 1 equal to when pi of z by psi of z, then limit z tends to pi by 2. So pi of z by 2. So pi of, what is the formula this? The formula is nothing but pi of pi by 2 divided by psi dash of pi by 2. So pi of pi by 2 value 1 by psi dash of pi by 2 minus 1. Then when z minus pi by 2, again residue 2 pi of minus pi by 2 divided by psi dash of minus pi by 2. So pi of minus pi by 2 minus 1, then psi dash of minus pi by 2 1. Again this is a minus 1. Therefore Cauchy residue theorem, integral over c f of z dz equal to 2 pi I into sum of the residue at the point 1 z1 z2 zn. Therefore this problem integral over c tan z dz equal to 2 pi I into r1 plus r2. So 2 pi I r1 minus 1 r2 minus 1. Therefore minus 4 pi I. So this is our answer. Thank you.